Hello students, last time we have seen the introduction of critical damping, and then we have seen undamped vertical shaft with the single rotor. Okay, so it is a very important theory last time we have discussed. Okay, so now you should keep in mind this figure, and let us understand the next topic is damped vertical shaft with single rotor. So it is also important topic. So here you can see this figure. So here this is a dotted line, or we can say center line. It is like a shaft, and this dark line is called the rotor. Okay, now the center of the shaft is O, and center of this rotor is S. So here you can see this is a shaft, and this is the center of this shaft. Okay, say O, and center of rotor is S. Okay, so I hope that image is a top view of this. Okay, this image. Okay, so you can understand this is a shaft, and this is a due to deflection. Okay, this is a center of rotor. Now here a shaft carrying a single rotor with eccentricity and having damping will have the following three reasons, three forces on the disc. So first is centrifugal force of magnitude MA omega square. So here you can see this is a centrifugal force due to this magnitude MA omega square, right, along the line of OG. Then second is restoring force of magnitude KY. So here at the beginning the rotor will be here, center of rotor will be here, and now the center of rotor will be here. So it try to restore its original position, that is called the KY. Okay, so restoring force of magnitude is KY at the geometric center S along with the line OS. Then next one is the damping force at the geometric center S in a direction opposing to velocity of point S. Means here you can see this is a direction opposite to the velocity of point S, that is the Cy omega. Its magnitude is Cy omega, that is the damping coefficient into linear velocity. So the direction of this force should create a moment opposite to the direction of rotation about the point O. Okay, now this figure OGS we already let it draw it again, OGS, and here this is perpendicular line from G. Okay, and this angle is called the phi, and this angle is alpha. Okay, so here you can see this is a distance, this is a Y, and this is E distance, right? Now here let alpha at the angle of rotation of centrifugal force MA omega square. So here like A is the distance from O to G, like MR omega square. Actually what we write for the centrifugal force, MR omega square. So instead of R, here we select as A. Okay, in a with the horizontal. Now sigma fx is equal to 0. So here you can see from the point G, if we consider the horizontal force, then it is MA omega square cos alpha, and if we consider the vertical force from G, then it is MA omega square sin alpha. Now for particular sigma fx, all the horizontal force will be the 0. So MA omega square cos alpha, which is on this side, and ky, which is on this side, restoring force, so opposite, that's why it is a minus ky, right? Now so same way sigma fy, that is here vertical MA omega square sin alpha, and here downward Cy omega. So here MA omega square sin alpha minus Cy omega. So here we get the answer in the form of MA omega square sin alpha is equal to Cyw, and here MA omega square cos alpha is equal to Ky. Right, here it is not seen, but you just understand that MA omega square cos alpha is equal to Ky. We can write this. Okay, now let's again consider the triangle OSG, in which eccentricity E makes an angle phi with CG, like it's talking about this figure, right? So triangle OSG, here O, S and G. If you see this triangle, let you draw this triangle and then see from figure whatever you have drawn. So cos alpha is equal to ON upon OG. Cos alpha is equal to ON upon OG. Okay, so again ON is equal to OS plus SN. So Y plus E cos phi, E cos phi. So this distance SN we can write as a E cos phi. Okay, so Y plus E cos phi upon OG, that is A. Okay, so here A, if A comes to this side, so A cos alpha is equal to Y plus E cos phi. Now same way sin alpha, so Gn upon OG, and Gn is equal to E sin phi. So Gn upon OG, so Gn is equal to E sin phi, and OG, that is A. Okay, so here you can say sin alpha is equal to A sin alpha is equal to E sin phi. Okay, now next is substitute this equation like cos alpha का जो ये equation है and ये equation है 3 and 4 in equation 1 and 2. so 1 cos alpha की जगह हमें रखना है and यहाँ पे 2 में sin alpha की जगह रखना है. ठीक है, so here A cos alpha and here A sin alpha की जगह हमें क्या रखना है, y plus E cos phi and यहाँ पे रखना है E sin phi. so here m omega square y plus E cos phi is equal to ky, and same way sin phi के लिए होगा m omega square E sin phi is equal to cy omega. Okay, now here simplify this equation. If simplify this equation, then here multiply with y and E cos phi, so here is equal to ky, and finally you just pause the video and see how it is derived. Actually it is very simple. So here m y omega square, y multiply with m omega square, and E cos phi multiply with m omega square, so is equal to ky. Then m y omega square come to this side, then cos phi is equal to, finally y is common here, so k minus m omega square upon m omega square into y upon E. Okay, and if we derive it again, if we solve it again, simplify it again, then k is common and m omega square upon k upon m omega square. So m upon k, that is, here we can say omega n square upon omega square, because here k upon m is equal to omega n. Okay, so here we can say k upon m, that is the omega n square, and omega n square upon omega square will be here, so into y upon E. Now finally cos phi is equal to, if we convert this into radius, then we have an equation 1 upon r square bracket 1 minus r square, so omega upon omega n, that is the r, so y into y upon E, and finally we got this equation. Same way, if we simplify this sin phi equation, then cy omega upon me omega square, so it is simple like from this equation. So here sin phi is equal to cy omega upon m omega square. Okay, and E over there. Okay, so y upon E, so both equation in the form of y upon E. So here c by m is equal to, we can say 2 zeta omega n, so here 2 zeta omega n upon omega into y upon E. So after find out again solve it here, so it's r omega upon omega n, that is r, so 2 zeta upon r into y upon E. Now let's again sin phi upon cos phi, so put the value of this sin phi and this cos phi over here, so it is tan phi, and final of this solving 2 zeta r upon 1 minus r square, in which phi is the phase angle, right? So here sin square phi plus cos square phi, if we add this equation, then it is equal to 1. So we have a sin phi and we have a cos phi, so put the value over here is equal to 1, and then again simplify this equation like this equation, right? We have to simplify this equation, so here y upon E is like common. Okay, and all other things comes to this side, okay, and the answer will be r square upon under root 1 minus r square whole square plus 2 zeta r whole square. So here 1 upon these things is called the we can say psi, okay, or we can say ohm, okay. So here into r square, so it is the magnification factor, or we can say magnifier or response, okay. Now so friends, this is our final answer, y upon e, that is r square upon under root 1 minus r square whole square plus 2 zeta r whole square, okay. And we can as I said, like we can give the answer like this also, okay. So friends, thank you. Jai Hind, Jai Bharat. Next time we will see the example related to these theories, okay, for the critical speed of the shaft.